I'm going to start recording. Hi everyone, good morning everyone. I apologize, I cannot attend the class in person today, so I recorded this lecture session and someone is going to play that for you today. And it's just like usual, we have some presentations on the material, and then we'll do some demo, show and tell on some of the materials that we cover. Okay, so let me bring this down. First thing, we'll go to full screen mode. I also have the YouTube recording session running, so we have a backup in case there's any problem. So occasionally I will check on that just to make sure it's still running, and I believe at this point the camera and then the speakers are all working. So I'll go to full screen mode, then we'll look at our schedule and also the materials that we cover today. Okay. Give me 1 second. Okay, I believe, yes, the full screen mode is working. So let's go to look at our schedule. Before we do, we want to make sure the YouTube, yep, still working. That's good. So we have talked about this schedule on Tuesday. So I have postponed the assignment. This is the first assignment that you have on objects. And I have done some show and tell on Tuesday how to do that, and I'm going to show a little bit of it that will lead us into polymorphism. That's the subject we're going to talk about today. Okay, make sure you spend time studying inheritance and polymorphism, and hope you can finish the assignment by this weekend. And also please read ahead and look at the final project, part 1, at least the part 1. And if you could, also read the requirement on part 2. And we will start looking into those the next 2 weeks. Well, we are talking more about the OOP features. Okay. Let's look at our modules. Okay. We have completed inheritance and some exercise, and we have talked about the templates last time, and we'll cover polymorphism. That will complete this session, and then we'll start looking into other subjects next week. To begin with, let's take a look at polymorphism. I will change the, so you can read on the screen. Yes. So basically polymorphism, we talk about inheritance. So the children classes can inherit features from the parent. Okay. But because they share some features, the parents and the child, so we can use polymorphism. By its name means with many forms, okay, polyforms. So you can fake kind of one class to the other. And you ask why we do want to do that. It's because if you do that, you can generalize some of the functions and methods by using polymorphism to apply to different classes, the subclass, the derived class, or the parent classes. Okay, we'll look into how we can do that. To do that, I also mentioned the last time, we have to use pointers. Some of you were a little bit concerned why we have to learn pointers and don't know how to use it. And this is one of the important features in OOP, polymorphism. And to do that, we have to use pointers. We'll go through a couple examples today, look at how we can do that. So if you don't remember how pointers work, please go back and review what we have covered and also the examples in the file section. I have a couple of examples, programs that you can review again to understand better what pointers and references means and how we can use them. Because if you don't, you may be confused when we try to do polymorphism. Okay? As I said before, the most important features in OOP are encapsulations, private public data, protected data. Second is inheritance. We talked about that last time, how to inherit features from the parent to the child. The third one is polymorphism. Okay? You can ignore this part first. The addition operator is a little bit like polymorphism, but this is overloading. And I'm not sure why it's put in this place. But when we look at this description of polymorphism, okay, to allow you to implement a function in different ways. Okay, here's an example. Say when you model birds, you say all birds fly in general, except some exceptions, like turkey and things like that. Okay, but then they fly different ways. The principle is the what and how. Okay, so read this, try to understand that. We'll go to that particular website and look at this example, and I'll try to explain to you what that means. And afterward, we'll go to Visual Studio, and I have written another example, I think a simpler one, and we can work together to do a show and tell how it works and why we do it. What's the advantage of doing that? Okay, let's go to that particular website first. Okay, the description here is same as in the module notes. Let me change the percentage setting so you can see better. Okay, so basically you want to define a class called bird, just a general common class called bird, and the only thing you have in there is a public method. Okay, now we haven't talked much about virtual. Virtual means is abstract, an abstract class, abstract function. That means it's a placeholder only. It doesn't have anything in there. This is a syntax for pure virtual function. So the word virtual is the keyword. Then you just define any function like similar to the normal one. When you say equals 0, that's called a virtual function, pure virtual function. That means it's a placeholder, does not have anything. The reason is that means when you create a child from this parent class, you need to and you must replace and define this function in your child class, the derived class, to override it. Okay? Otherwise, the compiler will complain and say you don't have this defined in your subclass, the derived class. So this is just a placeholder. That's just a syntax. Okay? And they must be using the same name, like below, when you define something. And we'll explain it, okay? So, if we want to have a generic function called migrate for all birds, okay? Then we say all birds, so it's a pointer now. Remember that asterisk is a pointer? So all birds fly. So it will call a function fly. We don't know how yet. Okay, we know what it is, it's fly, but we don't know how yet. So it will be defined in each subclass, the child, how they fly. Okay, here's example. If you define a swallow, which is a class, a subclass or derived class, a child class of bird. Now you must override that virtual function. Okay, that means the true function is defined here. Here in the parent is a placeholder, but in the child classes, you have to define the actual function, which is flap wings like crazy. It's just an example. So you have to define a function here for fly. Okay. So is another derived class, and you have to define another function to override the virtual one in the parent. And this one glide majestically over the waves. Okay, now we have two child. Each of them has their own fly function to override the parent's virtual function. If you do not define it here, then the compiler will complain and say your subclass swallow do not have a fly function. You gotta have a valid function. Okay? So why we do that? To do that means when you call bird and ask to execute the function fly, it will select the correct one to be used based on which derived class you are calling from. Like this, you give it a bird pointer, so it could be either of the derived class. And if you just use that to call fly, then it will find, during runtime, find the correct class and use the correct function to run. That's polymorphism. So one bird function call can go to different subclasses and run different program based on which subclass they belong. So polymorphism of many forms. Okay, that's one example. Okay, so inside the program you can do that. You can create two subclasses and you can do migrate call and give them the pointer. Based on the pointer, then the different fly function will be called, because bird is a parent class and it has a fly function in there, but during runtime it will be replaced by either one of them, depends on which one you provide. That's polymorphism. Now also remember, if you use a pointer, you have to use this dash greater than symbol instead of the dot notation. Last time we talked about that, so please remember, since we are using a pointer, you have to do that. Okay, that's one example. That means one function call can polymorph into different ones depending on what was provided. Okay. That's polymorphism. In case you want to read more about it, please follow the link in here. We'll come to this website, okay, and look at some of the examples they provide, or of course other websites that we pointed out before that you can go to and look at their tutorial and more examples on polymorphism. Okay. Polymorphism itself is not difficult to understand once you look at a couple examples. However, it is sometimes more difficult to know when you want to apply it, right? If you don't, you will then have to implement multiple migrate call. And each time you call by a different migrate by swallow, migrate by other, so it depends. So that means you have to have multiple migrate function to do that. But by using polymorphism, you have one function and you have 10 subclasses, and you can just use one function to do that. So it makes polymorphism very useful and effective. Okay, that's the reason this is one of the most important feature of OOP. Okay. I will provide another example and hope you further understand what polymorphism means and how we make use of it and what's the advantage using it. Okay. But as I said, please go to the internet and read the book first, of course, and go to the internet, do some research on it, and look at more examples so you can understand it better. Okay? Before we go to Visual Studio, let's make sure the conference is still, and the speaker and camera is still running. That's good. And making sure the YouTube recording is still working live. That's good. Okay, now let's close this down and we'll go to Visual Studio. I already preloaded the program, save some time. So let's go back a little bit on the book objects program last time, and then this will lead us into polymorphism next. So remember last time when we defined a broadcast for the previous assignment, we defined private data, public data, and public function calls, methods, and you have to define them and complete the class. Then you can use the class there, right? Remember one thing about another section called protected. We haven't used it yet. Protected. Okay. The protected data in the parent are similar to private for the public, except the protected data could be inherited by the children classes. That's the difference. Okay, so just remember that. That's inheritance. So that's the basic structure how you define a class. The public section, the private section, possibility of protected section for inheritance, and then definition of the functions, methods. So when you define a class, you always do that. So class, the name, and then begin and end of the definition of the class. Okay, that's the whole class structure, and you can define other functions outside, but you have to use the name book associated with them. Okay, that's the normal way. And remember the getter and setter examples that I provided here last time we explained it. Now we go to a different program. There's another demo program I created. It's for displaying area of a geometry shape. Okay, so I include two heading files. One is one and one is just inheritance and polymorphism example. Okay. So I define a prototype display area. I only want one function to display area for all geometry shape. And as we know, each of the geometry shape like triangle, rectangle, circle, all are defined with a different formula. Okay, so by using one method, one function call, and using polymorphism, I do not have to have multiple functions called display triangle area, display rectangular area, display square area. I don't need that. By using polymorphism, I have one function call. using the parent type geometry shape. And I can do that. I'll show it to you in this example. But before we go to polymorphism, let's go backward a little bit, look at inheritance first, and to migrate from inheritance and how to do polymorphism. So normally, we define a class. And we want to define classes in the header file in general. The reason is that means you can have other programs include your class definition. Okay, so your classes could be used in multiple programs. So that's what I did. So I include two class definition. One is for inheritance, one is for polymorphism. Okay, let's look at the inheritance first. So I further enhance a class. Now I have a general class called geometry shape. And in the public area, I have, of course, the constructor. So I have our statement saying I'm in the constructor. I also have some public methods. Remember we say to protect your data, you do not want your data to be in public area. Normally we put it in private, right? That's what we did in the object. We put in private. But because in this case, we want to have children classes, to inherit those features, so we put it in protected. Protected means it's private to the world, except it's inherited by the children, so the children can see them. That's protected, so that's what I used. Okay, so I have the length and width. Just to make it simple, we do rectangle and triangle. Okay, of course you can use different shapes too, but just use two to demonstrate this inheritance and then polymorphism. So now I have two data will be inherited by the children class. One is the length, the other one is the width, which exists both in the triangle or a rectangle. Okay. Since they are protected data like private, so I have to use the setter and getter for each of them. So I have a setter length for the length value and getter. So it's on the width, and they have to be public accessible so that the outside world can use your function to access to the data. But the data itself are protected for direct access, so they cannot mess around with your data. That's the purpose of encapsulation. So I encapsulate this data into the protected area only for the parent and the child classes. Yet I provide public accessible methods to modify the data or getting or reading the data if it's needed. So for every protected data, you will have a setter and a getter. Usually the setter is a void function, and the getter, of course, is to get back the data, so must have some data type. That's another common practice people will do when you define a class. Of course, we also have to have those methods to be defined, and I define it outside the class block here, so I need to use the geometry tray and double colon in order to relate that function to the class. So when you double click, and you will see the highlight, and when you same thing on the other one, so the compiler, the editor know this belongs to the class. So I define the set length, get length, also setter for width and the getter for width. Quite simple. They enter a new length and you input into the object. Same as when you get length, you just return it back to the user. So it's on the width. So that is the common way, a normal way to define a class. Particularly putting your data inside the protected area if you have child classes like this one. We have a rectangle class defined, which is in the triangle class, two derived classes. They were derived from the geometry shape. So it's a proper inheritance from the geometry shape. That means they will have length and width, and also all the methods, since it's proper, available to those subclasses, rectangle and triangle. So, of course, each of the class will have a constructor, so we'll do the same thing. A constructor, default constructor, just print out, so it's on the triangle. And they must have the same name. In this case, I define the constructor inside the class. So that's called inline definition. Inside the class. Previously, we defined those outside the class, but here we define inside the class. That's why we don't need triangle : because it's already inside the class. That's the only difference. Otherwise, they work the same. But in addition to the constructor, we also have a function called, say, calculate area. Okay? So each of them has a different method, because of the formula is different for each type of shape. So for rectangle, it's length times width. Of course, triangle, length times width divided by 2. So they're different. They need to define inside the subclass, the derived class, because they are more specific. As we said, specific data need to be defined within the subclass, the derived classes. So that's what we did. So each of them will have their own constructor and their own calculating area function. Okay? If you do that, now look at the program, how we use it. Inheritance here. So if we have a rectangle defined called new rectangle, and we have a triangle defined called new triangle. So the first thing we do is to use set length. To set the rectangle to be 3 by 2, I use new rectangle dot, because it is an object. You instantiate an object here, so you can use the dot form. But if you use pointers, then you have to use dash greater than, right? Since we have an object, so we can use the dot notation. So it's new rectangle dot set length and set width. So it become a 3 by 2 rectangle. So now, if we want to find the area of the rectangle, all we have to do is rectangle dot calculating area. So same thing on the triangle, you set the length 3 by 2. Then the area of triangle, you call particular objects using their particular function, and then you can get the area. So if we build it and make sure when you run, just look at the first block. Okay, the second block is for polymorphism. I'll discuss that soon. But for the first block, so when you create a new rectangle, it will first call the parent first. Geometry shape is the parent. After that, it will call the rectangle constructor. Same thing on the triangle. When you create a new triangle, the first thing it call is the geometry shape constructor, then it will call the triangle. Okay? Then based on these two, calculating area, we get 3 by 2 is 6. 3 by 2 is 6 divided to 2, it become 3. Okay? That's what it is, inheritance. Okay? Now, that's easy. We have learned that previously. I just show you another example how to inherit the protected data. Since we never see example, so I show you how to inherit the protected data, okay, from the parent. Okay, and the mix, and also how to use setter and getters. But you can see each of the objects, you have to name them specifically to call that, because the calculating area is different. Okay. So that's all for inheritance. Let's look at polymorphism. Now I define another one called rectangle 1 and triangle 1. Let's look at what those are for. They are the same function just like the previous one. Of course, I have to name them differently because otherwise there will be a conflict. So everything is the same. So you have getter and setter, you have protected data. Okay, everything the same except this line. Now I define a virtual function called calculated area that will return a double. I put equals 0 is a pure virtual function. That means it's only a placeholder. It does not have any meaning other than a placeholder. Okay, and the name. Okay, it's a placeholder. So that's the only line I add into geometry shape 1, which is identical to the other. Its subfunctions methods are identical. The whole class for geometry shape 1 is same as geometry shape except this line. Okay? Except this line. Okay. Yep. So now, what's the difference? Because we have a virtual function here called calculating area inside the parent, so I have to define, which we did. Okay? We have to define a calculating area to replace. So this is identical to the previous one except the name. I change it to rectangular 1. And of course inherit from geometry shape 1. So everything is identical except the name change. The only difference is I put in a new line here. That's it. If you compare those two carefully, you'll find that's the only difference other than the name change. You put a virtual function inside the geometry shape as the parent, as a placeholder, then whatever defined here will override that one. Okay, and everything else the same. Then look at the main program. So now let's show you how to do polymorphism. Now we have rectangular shape 1, a new one, and the triangle 1, a new triangle 1. Same thing, when you want to use the objects, you want to do set the length and width. So it's 6 by 5, any random number. And then now you can call one function called display area. And you give it the pointer of your object, a rectangular object. Same thing on the triangle. You set the length and width, and you call display area, giving it the new triangle pointer. So I'm calling the same function, but I'm providing a pointer of different type. One is a rectangle, one is a triangle. But because rectangle and triangle both derive from a geometry shape, so they are siblings and they share multiple things, even though they have their own calculated area. But since I use the virtual function in the parent, that means all functions within those individual derived classes will have the same name. Okay, right? Because of that, I can pass that to a generic function called display area and use the generic name, the parent name, geometry shape. So I don't care if it's a triangle or a rectangle. I use the parent's name and define as a pointer. Now it's pointing to a new shape. I don't care what shape it is. Then I can just make call. Because it's a pointer, I have to use the dash greater than notation, right? Not the dot notation. And I can just call calculating area. Since they are all of the same name, I really don't care what shape they are, whether it's a triangle or rectangle. They all have a function called calculating area, implemented separately inside their own class, subclass. So all I have to do is using the parent's pointer, and that will polymorph into a rectangle or a triangle during runtime. And then execution will know which calculating area to be used for that particular child class, child object in this case. So you see the beauty of this. You can have generic function used for all subclasses, all child classes or derived classes, whichever name you want to call it. So you can have one generic function one generic function and enter that width parameter using the parent class. But yet it could be applied to all derived classes, since all of them using a shared common name on the function, since I do use the virtual function placeholder inside the class. And all of them will have to, in order to compile, they ought to have calculating area in each of the derived classes. So when I make this call from the parent side, I call the virtual function, but that was overridden by their derived classes local calculating area. So now you see the beauty. I can do display area once, but then can apply to hundreds or thousands of derived classes, as long as they were derived by the same parent using the virtual function. That's polymorphism. Okay, so you see the advantage of doing that. Okay, so when you run, same thing. So it runs the same. It will go to construct a rectangle. So we will call the geometry trait, then the rectangle, so it's on a triangle. And then when it call calculating area, okay, when you call display area will call calculated area, then it will display 30, 6 by 5, and then 15 for the triangle. Okay, so that works. So that's polymorphism. Okay, I will post this into the file section, this in inheritance and poly program, so for you to reference. Hope you understand how to use inheritance and polymorphism. If you need more example, as I said before, please go to that website or go to internet and look for C++ polymorphism, and you will find many examples. Some of them are more difficult to understand, or the way they explain it could be more difficult sometimes. So I hope this simple example will give you an idea how to do that and the advantage of doing that. So instead of calling rectangle calculating area, so you have many different calls. Say you have 100 different types of shape, and now you have to, in order to display that, you have to call different functions based on the object. But by doing this, you don't have to. Each of them, if you go through the list of items, you can make call to the same function, display area, and it will take care of the polymorphism by using the parent's name. Okay, so I will put this into the file area for you to review. Okay, let me see. I think that's all for the polymorphism. Let's go back to our class. Let's make sure the recording is still working. Seems it is. Good. So that's polymorphism. That's the website. There's no slides presentation for this particular topic, but these three features: encapsulation using public, private, and protect sections inside the class are very important features for OOP. So please make sure you read those descriptions again and make sure you understand them, and also look at some of the examples that I provide in the book or on the internet and how to use them. Because when we go to the C++ class 2, we will start from there, inheritance and other features of the OOP. Okay, so it is very important. We have not talked much about OOP design in this class, other than introduce you to the most important features of OOP. Those 3 features and the syntax and why we use them. We will do more on those in your second class of the C++. Okay, but before you have to understand the meaning and the purpose of those features. Okay, let me see. Let's go back our calendar. That's for the assignment. Changing the book collection. Okay, that one we have talked about. And that's the next assignment is in the final project. Okay, so you have to make use of all the OOP features that we have talked about so far. And I will do some demonstration the next 2 weeks concerning about your final project and what the expectations are, and hope you can provide and finish those 2 by end of this semester. That's all for today. It's about 45 minutes. I think that's it for today. And let me close down the full screen. Okay. So that's all. Thanks for attending. And if you have any question, jot it down, send me an email, or bring it up next week, and we'll talk more about this. It takes a couple of weeks for you to digest this concept and also how to make use of them. Okay? Thanks. I'll stop the recording now. Thanks for joining. Bye-bye.